Right, our last speaker for this section before afternoon tea is David Pattemore from Plant and Food Research in Hamilton, and he's going to talk on beekeepers growing bumblebees, a key step towards a new model of pollination service provision. David Pattemore, welcome.
Kia ora, good afternoon. Thank you for the opportunity to talk. So I'm going to give this afternoon just a very quick overview of a 5-year research program that we've been conducting to develop a new method of producing bumblebees so that bumblebees can really become a key player in crop pollination in New Zealand. So the context of this is, first of all, honeybees are by far the most important crop pollinator globally, and that's not going to change in a hurry. We can bring in large numbers of hives with large numbers of bees in each colony really easily, in and out of orchards when we need them, and that makes them just ideally suited for bringing in for crop pollination. But they do have some limitations. We know that for some crops, the crop that you're trying to get them to pollinate is not highly preferred by the honeybee, and the bee will then go and try and find something else to forage on instead. We also have, as many growers of things like almonds and cherries will know, in cold weather, it's often quite late in the day before the honeybees will actually get out and start foraging. So there are some limitations to the use of honeybees, but they remain the most important crop pollinator globally. There have also been some interesting challenges that we've seen in the use of honeybees as pollinators. And this graph, using data provided by MPI's Apiculture Monitoring Report, just shows the range of hive rental prices for pollination over the last, I think it's 6 years here. And so let's see if I can get these colors right. The dark green bars show the prices for kiwi fruit. Light blue, or blue, is seed crops, and then orange is other fruit crops, such as pip fruit and stone fruit. You can see that for a lot of these crops, this dotted line is inflation. So if your hive was $110 6 years ago, this is how much it would cost just based on the increase in inflation. Most of them are tracking with inflation, but we see this huge jump here in the case of bees going into kiwi fruit. I'm sure if you're involved in crop pollination, you know what that is. That's largely due to the fact that kiwi fruit growers have started to use big netted canopies to cover their kiwi fruit crops. And that has led to concerns about the health of beehives that go in it. And when you put this situation with netted crops against the fact that beekeepers could be out there collecting a good Manuka honey harvest, it's really seen increasing reluctance of beekeepers to put the hives in for pollination in those particular crops, which has meant that prices increased dramatically, that growers are having to pay a much higher price in order to secure their hives. So this is an indication that in this particular crop, in this particular situation, there is a greater demand than there really is ability to supply, and that's why we've seen that big price increase. But there's also increasing demand for bees beyond what we have already. And if we look at the ambitions of our crop industries for their growth over the next 10, 20 years, they're all wanting to grow. They're all wanting to see increased planting areas. So Zespri says in their documents they want to see 50% growth in yields by 2027, 150% growth in revenue. The avocado industry wants to see their revenue grow by 180% by 2023. These are really ambitious goals for growth in these industries, and these are just two of the crop industries in New Zealand. So if we just assume that only 50% of that growth is from new planting areas, maybe the other 50% comes from increased value of the crop. And if we assume just an average colony stocking rate of 8 honeybee hives per hectare, these two industries alone, we're talking about 25,000 more colonies in 8 years for kiwi fruit, 27,500 more colonies for avocado pollination in just 4 years. So we have a real question here in New Zealand about how are we actually going to ensure that we're providing sufficient pollination services for the crop industries that rely on pollination, especially in the face of other competing interests for honeybees, especially Manuka honey production. Now, we noticed that this was potentially going to be an issue several years ago, and we developed a research program that was funded by MBIE and several crop industries to look to develop new pollination systems for growers, to give them a range of tools that they could use. And in this program, we had 3 main objectives. The first thing is we wanted to know how could we use all the unmanaged pollinators that are already out in the orchards, the flies and the beetles and the moths and the native bees. And then our second objective was to take one of those unmanaged pollinators, bumblebees, which exist throughout New Zealand, occur naturally in the environment, and say, well, how can we actually use this species in a managed way for pollination in open orchards? And the third objective we had was how can we actually control honeybee behavior to make them more efficient? So I'm going to talk today about where we've got to in terms of the use of bumblebees. Now, I'm sure many of you are aware that bumblebees are used for tomato glasshouse pollination in New Zealand quite considerably, but the economics of that system means that the per colony cost of bumblebees is around $130 to $160 per colony. Now, the work we've done has shown us that for most of the crops we've looked at, we really need to consider using 4 bumblebee colonies for every honeybee colony to get the equivalent amount of service. So we've been working really hard to develop a method where we can actually rear bumblebee colonies and produce them for crop pollination at a strength and a cost where these 4 hives of bumblebees are equivalent to a hive of honeybees. And so in this example here of the stack of 8 hives, 8 colonies, that would be equivalent to 2 honeybee colonies. So that's really been our focus, is developing the methods to ensure we're getting good, strong colonies, but also making sure that the methods we're using to rear those colonies keep that price down at a level where it's going to be price comparable to honeybees. One of our main focuses has been looking at the use of bumblebees in kiwi fruit. And as I said before, this concern about the effect of nets on honeybees has been one of the reasons why Zespri especially has been very supportive of our research here. And so this is the netted canopy that is over most of the new gold variety crops now in the country. And bumblebees, we know, perform better under nets than honeybees do. Honeybees do tend to have issues with navigation under nets, and we do see evidence of declines in colony strength under nets. And so we've been really focusing on developing our system in the first instance to use in kiwi fruit orchards. And so what we were able to do this last year was actually to complete a full orchard trial of bumblebee pollination in kiwi fruit orchards. And this is because we've done many smaller trials over the last 5 years to really understand how bumblebees operated in orchards and get to the point where we were confident that they could do the job of pollination. And we were able to work with Zespri and a grower in a single orchard of 2.5 hectares. It was completely covered, and we didn't put any honeybees in that orchard at all. The only bees we brought in were bumblebees. We brought in the bumblebee colonies we had produced. And so that was the primary pollinator in this orchard. Although, to give the grower assurance that he would still get a crop, we then wet sprayed artificial pollination throughout the whole orchard, apart from 20 bays that we marked out so that these people who were spraying individual flowers didn't spray the bays that we had marked for pollination. Now, this is not an affordable way to go about pollinating your orchard. You see, each individual flower in that orchard was sprayed individually with a sprayer. But this, at a high cost, gave the grower the assurance that they were going to get a crop. But by marking out 20 bays that weren't touched by these artificial sprayers meant that we could, in those bays, assess the contribution of just bumblebees to pollination. We also then had a further 20 bays where we were able to bag flowers before they opened. Then we opened them just when the sprayer went past, and we bagged them again, so we get a measure just of the contribution of the artificial pollination. Then we also looked at flowers that were left open to be pollinated by both bumblebees and the artificial pollination. And so this gave us a really good picture about what would happen in an orchard if you just left it to be pollinated by bumblebees alone. And this is the results for fruit set. So these are the mean percentage fruit sets across those 20 bays that we monitored. And so the air shear is that method of artificial pollination, and the screen bar is what we found on flowers that were open for both the artificial pollination and the bumblebees. So we had around mid-90s fruit set, and there was no difference between that and bumblebee pollination happened towards the middle of the flowering season. This light blue bar is the early stage of flowering in the orchard, and we did see a drop in the rate of pollination, a rate of fruit set in those bays, but it was very similar to the rate of those the individually pollinated flowers using the artificial pollination system. So for a start, this is a really fantastic result to get to clearly see that bumblebee pollination is doing the equivalent job of even that individual spraying on individual flowers. And in fact, that job that bumblebees were doing improved in the later season. If you look then at fruit weight, which is a better measure of what's actually happening in terms of the amount of pollen that's been put on flowers, we see that there's no difference across the open flowers or left to be pollinated by everything, the artificially pollinated flowers, and those flowers in the later season. We're getting the same weight of fruit. There was a drop here with those early bumblebee flowers. The flowers are pollinated just by bumblebees at the early stage. And that's really about the fact that we had very few male flowers open in the orchard at that early stage. And so the pollen was really a limiting factor for pollination. In an ordinary orchard, if you hadn't been running a trial, the grower would have come through and sprayed a dry application of pollen throughout the orchard because there wasn't enough pollen available. So even if this had been honeybees, we would have seen lower fruit set and lower fruit weight in that early period. But when we look at the middle of the season, when we've got good male flowers open in the orchard, we find that the bumblebees were absolutely up to the job of pollinating these orchards. So this is fantastic results. This just visually shows you what we got. This is the sort of the size of the fruit in a 25 count tray that are from that early pollination from bumblebees, but we were really getting some really massive fruits in that orchard from those other treatments. So we're really encouraged by these results, and we're really wanting to move on to the next step, which is to basically commercialize this approach and get it out to growers and get it available as an option. So we've developed this, we've called the system that we've developed Bumblebox, and you can go and have a look at our stand, the Planted Food stand, for more information about this. But basically the process involves capturing queens and putting them in these racks where we rear them. We've developed these racks that can be used in any environment, in anyone's shed, plugged into the wall and used to rear the queens. Those queens then produce colonies. Those colonies are then put into these boxes, and those boxes go out into the field for pollination. And so what we're really aiming to do here is make the system of producing bumblebees something that's very accessible, especially to beekeepers who know social bees and have an interest in bees, and makes it something that people can really do and be involved in. And we've done some further refinements. We've now made those trays in a modular form so that you can basically, whatever space you have, if you just have a table or if you have a shed, you can build your production level to match the space and the capacity that you have to be involved in pollination. And so just the whole vision of where we're going with this is we're saying, currently what we have is that growers pay beekeepers to bring in hives. Those beekeepers put the hives into the orchards of the grower, and that produces then fruit for then the grower sort of manages the hives from there. But we really see that although that works for honeybees, if you're starting to have multiple different options for pollination, it's much more difficult for the grower to manage that process. And there really could be a role for the grower to contract a pollination service provider who then has access to honeybees, bumblebees, maybe flies, artificial pollination, and can come up with a tailored solution for each orchard and pay and basically provide pollination as a service, not just colony numbers. And we really think this concept of pollination service provision could really be transformative for growing industries in New Zealand, could provide a really good revenue source for beekeepers, and enable us to keep up the pollination service for the growing industries in New Zealand that are just really wanting to expand what they're doing. So that's really our vision, and if you want to come and talk to us more about this, and if you want to be involved, come and see us at the Planted Food stand out in the trade hall. Thank you.